All right, baby's sleeping right now. Time to do what I love. Some Algebra 1. Yes, distributive property. All right, so anyways, hopefully you just did the last assignment, 3.2.3, for real this time, out of your textbooks. Hey, it was nice to get textbooks back today. Anyways, you had to do these problems. The answers are all there, right? 354, 355, 366, 367. Closed sets, that's a little bit confusing, okay? That's a little bit confusing. I'm not going to go over the closed sets today. It's not super important you understood the closed set stuff, but I tried to do it on out and try to explain it, so maybe you got something out of this here. Anywho, this video is about the distributive property, which is always something that every algebra student should know, the distributive properties. That's why I'm making this video. Everybody should know this, what the distributive property is, because my guess is that when you did 356, maybe you set up a generic rectangle to help you multiply. Look, these are written out as a product, not as a sum, okay? If I don't see any parentheses out here, it's because they're kind of invisible, right? When you see parentheses, what you got to do is multiply. Okay, and here we have kind of a couple tiles on the outside. This could be maybe the height or the length, and then this is the width. Okay, this is the height, this is the width, this is the height, this is the width, this is the height, this is the width. We need to rewrite it as a sum. So it might be easier, right? On problems like this, maybe you set up a generic rectangle. Does it say rectangles without using your tile? So maybe you did a generic rectangle. Or you could have done the distributive property. Okay, distributive property is pretty easy to deal with because you don't have to draw anything out, which is kind of nice. And the distributive property actually, it has a longer name. The distributive property, they don't actually write the name of the distributive property here. The distributive property is the distributive property of multiplication. Okay, put this in your notes. Multiplication over addition or subtraction. And I'm getting kind of messed up there because it's hard to see, okay? The distributive property of multiplication over addition or subtraction. The idea of this is that if I have a number on the outside, okay, directly on the outside, it's going to distribute over the addition happening on the inside of parentheses. This is just a rule. It's a property. It's the way that math works, right? The way that algebra, the way that we interpret what the heck this means when we have a number outside of an expression that's in parentheses right here. So what's outside distributes over what's inside right here, okay? And when we see parentheses, what does distribute mean? It means multiply, okay? Distributive property of multiplication over addition or subtraction. So let me get rid of this here because this is usually how your teachers are going to show you distributive property, right? When they're doing things out for you in future classes here, it's like, oh, I got a number on the outside here. What's it doing to the inside of this? Well, it's multiplying. It's not just multiplying to the b. What else is it multiplying to? It's multiplying to the c. Okay, it's multiplying to both terms, right? These are both called terms on the inside here. Hopefully you read this too. This is at the end of the lesson here too about polynomials. Polynomials are stuff like this. This is a term of a polynomial. This is another term of a polynomial. This is another term of a polynomial. Terms are separated by pluses or minuses, okay? Pluses or minuses here. So here I have term b plus term c. Then I have term a's being multiplied to both those things. Here it is, moment of truth. This is how you do the distributive property. It's not too hard. Check it out. The number on the outside here distributes to the inside, and they usually, right, teachers will show that with arrows like that. Just remember what's on the outside here is going to go to this guy, and it's going to distribute to this guy. And then you got to remember, what is distributive property? Well, it's the distributive property of multiplication over addition or subtraction. So this is a times by the term b, and then you still have the plus. That's kind of important here. So AB, right? A times B would just be AB. And then A times the term C would just be AC, written out AC, right? A times C, that means A times C right there. And that's it, right? That's it. That's one way to rewrite this from a product to a sum, okay? So down here, right down here, I'm guessing maybe some of you guys at least here, and I saw this on your exit tickets yesterday when I looked at them, you might have set up a generic rectangle for these. And you probably figured out, hey, I can do these in my head. Like this isn't that hard, right? I can do this in my head here. The height of this, or the length of this, is 2x. Okay. Do I have any other terms here? No. So I know that my height in my terms, if I stacked out tiles, I'd have an x and I'd have an x, and that's it. I just have two x's in terms of height. I don't need to have more than one row in my generic rectangle. Okay, 2x, and then my width is 6x plus 7. Plus 5. And I remember that to get an area of a rectangle, it's simply length times width, okay? Length times width, length times width. So I got to do my length is 2x, and then I got 6x plus 5 as my width, okay? So remember, to get the area in terms of pieces, in terms of a sum, simply area is length times by width. And so I just need to multiply this all together, okay? 6x times 2x, well, 6 times 2 is 12. X times x is x squared. 5 times 2 is 10, and then x times, technically, right, if you did the reading up here, actually, I point this out, oh, x to the 0th power. Okay. So 2x times by 5, and then 5 I can rewrite as and puts the standard form of polynomials is this, 5x to the 0th, right? Why would it be 5x to the 0th? Why would 5 be equal to 5x to the 0th? Well, what is x to the 0th equal? It's equal to 1, right? It's equal to 1. So this is 5 times 1 here. Anyway, I just show this to you too because sometimes people struggle being like, well, what's 5 times 2x? Well, 5 times 2x, well, that's the same as 5 times x to the 0th times by 2x. And then here, you just remind yourselves, the numbers multiply together. The coefficient is called a coefficient. They multiply together. 5 times 2 is 10, and x, right, is x to the first times by x to the 0th, right? If I have the same base here and I'm multiplying, what do I do with the exponents? What do I do with the exponents? What do I do with the exponents? I add them, right? X to the m times by x to the n equals x to the m plus n. Remember, that's a law of exponents here that we're hopefully reviewing this chapter. Okay, so I just get here 10x here. My answer is this, okay? 12x squared plus 10x. But what did I really do right here? I didn't need to draw out this generic rectangle. This is what I freaking do. Well, this number on the outside here, what does my distributive property tell me? This number on the outside, it distributes here. So you can do these in your head, right? You don't need to actually draw the generic rectangles. If I have a number on the outside, just one number on the outside, it's just going to distribute it, okay? On your classwork today, right, you had more complex stuff than this here. So I'm still hope that you're doing a generic rectangle. Definitely do a generic rectangle for if you have stuff that's not just one number on the outside. So here I have a binomial multiplying to a binomial. Well, my height's going to be this term plus this term times this term plus this term. Use a generic rectangle to kind of do stuff that's not just purely the distributive property here, okay? So, but if I have one number on the outside, it's easy to do in my head. Check it out. 2x times by 6x, well, that's 12x squared. 2x times by 5, well, that's easy as well, too. If I got 2x and I have it 5 times, right? 2x's and then 4x is 5, 6x is 8x is 10x. Yeah, 2x 5 times, yeah, that'd be 10x. 10x is total. I can just distributive property, get my answer there, okay? Here, right, my guess is you maybe come up generic rectangles with all these. Do you have to do that? No, you don't, okay? Because here, what is this? Is the distributive property of multiplication over addition, okay? Distributive property, right? The number on the outside distributes inside the parentheses here. 6 times by 4x, well, now I got 4x is 6 times. 6 times 4 is 24, right? It's okay if you're using a calculator, right? Use a calculator, get it out, right? Make that really quick. That should take you 2 seconds. 6 times 4, 24, right? Hopefully you have your multiplication tables memorized, but it's okay if you want to rely on the calculator, right? Just get it done, okay? So this is 24x. Oops, missed that there. Then I got 6 times 1 is 6. Got my answer to that one here too. Distributive property, right? Just distributive property in all these. I draw my arrows, like the number on the outside is going to multiply to both of the terms. And the signs are going to stay the same in between. So this is still going to be a plus sign here. If this were a minus sign here, it would just be a minus sign in between the resulting terms, okay? A times B plus A times C, right? As you see in the formula for distributive property. 3y times by 4x. So here, y times x is just going to simplify to y times x, or I'll write it as xy. Usually we see it as xy here. And then 3 times 4 is 12. So I get 12xy here, and I get 3y times by 3. Well, that would give me 9y's total. And here, right, distribute. You just distribute to all those terms. And then here we just have binomials. But if I had a trinomial, I'd multiply 3 times, okay? So now I got 7y times by 10x, and then that would be 70xy. And then I have 7y plus 11y, and that's going to be 77y squared, okay? And there you have it. Something that every Algebra 1 student should know is that you can distribute. Right, distributive property there. You don't have to necessarily do a generic rectangle when you have it as simply laid out as this. Thanks for watching. See you guys later. Bye.